coordinate system of CNC machine tools. When CNC machine tools process workpieces, the relative position between the tool and the workpiece is represented in digital form. Therefore, it is necessary to establish a coordinate system to clearly define the relative position of the tool and workpiece. The coordinate system has been standardized, and the right-hand Cartesian coordinate system is currently used as the reference coordinate system. In this system, there are three basic coordinate axes, also known as linear coordinate axes, namely x, y, and z. If you extend your right hand, the thumb, index finger, and middle finger represent the x and y and z axes respectively, presenting three linear coordinate axes. The direction pointed by the fingertips is positive direction of three linear coordinate axes. There are also three rotational coordinates A, B, and C. The rotational coordinate axes rotate around the x, y, and z axes, respectively. The positive direction of rotational coordinate axis is determined according to the following rule. The thumb points in the positive direction of the linear coordinate axis, and the direction grasped by the four fingers is the positive direction. This is the classification of coordinate axes. Next, let's continue learning how to determine the machine tool coordinate axis. There is a rule for determining the machine tool coordinate axis. When making a judgment, it is assumed that workpiece being processed is stationary, and the tool is moving, i.e., the principle of relative tool movement. Additionally, the direction in which the tool moves away from the workpiece is defined as the positive direction of the coordinate. Let's first take a look at the CNC lathe coordinate system shown in the right figure. While the direction in which the tool moves away from the workpiece is the positive direction of z-axis. How is the linear coordinate axis determined? There is also an order. First, the z-axis is determined, followed by the x-axis, and finally the y-axis. So, let's first look at the determination of the z-axis. The direction of the z-axis is determined by the spindle that transmits the cutting force. The standard specifies that the coordinate axis parallel to the spindle axis is the z-axis, and the direction in which tool moves away from the workpiece is the positive direction of the z-axis. Next is the determination of x-axis. The x-axis is the coordinate axis parallel to the guide surface and perpendicular to the z-axis. The x-coordinate is the main coordinate in the plane where the tool or the workpiece is positioned. Determination of y-axis. The y-axis is perpendicular to x and z-axis. The positive direction of y-axis is determined according to the positive directions of the x and z coordinates, following the right-hand Cartesian coordinate system. Determination of rotational movement. The rotations around the x, y, and z coordinate axes are represented by A, B, and C respectively. Their positive directions are determined by the right-hand rule. If there are additional coordinates parallel to the main x, y, and z coordinates, they can be designated as U, V, W, I, J, K, and P, Q, R respectively. This is the determination of auxiliary axes. Next, let's consider the actual situation to see how the specific coordinate system is determined. The left figure shows a CNC lathe with a horizontal spindle, so the z direction must be horizontal. But which way is the positive z direction? There is a rule that tool moves away from the workpiece. So, since the tool is mounted on the tool holder and the front tool holder moves to the right to move away from the workpiece, so we can determine that the positive z direction. is horizontally to the right. Next, we need to determine the x-axis. The x-axis also has a certain rule for determination. For machine tools where the workpieces rotate, such as ladders and grinding machines, the rule for determining the x-axis is that it must not only be perpendicular to the axial direction, but also parallel to the cross-slide guide surface. From this, we can deduce that the x-axis is horizontally perpendicular to the z-axis, and that the tool moves away from the workpiece. After determining this, because it is a front tool holder, it moves away from the rotation center, so the final determined positive x direction is horizontal and perpendicular to the z-axis outward. This is the direction of x-axis. Okay, let's continue with another machine tool. Here, we have a vertical CNC milling machine, which also has a spindle. For a machine tool with a spindle, the direction parallel to the spindle can be chosen as the z-axis, and the direction in which the tool moves away from the workpiece is the positive direction of the z-axis. After determining the z-axis, the next step is to determine the x-axis. For machine tools where the workpiece rotates, such as ladders, the math previously mentioned applies. Now, for machine tools where the tool rotates, such as milling machines, boring machines, and drilling machines, if the spindle is vertical, then you need to look from the spindle towards to the column. In other words, when facing a machine tool, looking from the spindle towards to the column, the positive direction of the x-axis points to the right. For this machine tool, the x direction is horizontal and points to the right. After determining the z and x-axis, the next step is to determine the y-axis. By finding the corresponding positions of the x and z-axis, where the z-axis is vertical and points upward, and the x-axis is horizontal and points to the right, it can be deduced that the y-axis should be horizontal and point inward. At this point, the three-coordinate axis has been determined. The method for determining the coordinate axis of a CNC gantry milling machine is basically the same as that for the vertical milling machine just mentioned. As for CNC horizontal boring and milling machines, the first step is to find the direction of the spindle. Then, determine the directions of the z, y, and x-axis in sequence, as shown in the figure. The method of determining the coordinate axis of a CNC cylindrical grinding machine is also similar to that of a CNC ladder, since both are machine tools while the workpiece rotates. For a CNC rotary table press, the first step is to find the spindle direction, and the direction away from the workpiece is the positive direction of the z-axis. After that, the directions of the x and y-axis are determined in sequence. This concludes the determination of the machine tool coordinate axis. The third part is the arranging of machine tool coordinate system. The machine origin is a fixed point, set during the design, manufacturing, assembly, and debugging of the machine tool. The machine origin is a defined point that cannot be directly measured, and users do not have permission to modify it. The position of the machine origin varies between different manufacturers. So, when operating the machine, you should refer to the operation manual of the specific machine system. The workpiece origin refers to the origin selected for programming the part based on the part's design drawings, also known as the programming origin or the origin of the workpiece coordinate system. It is a coordinate system origin artificially set for the convenience of programming. Its selection generally coincides with the design reference point, or can be chosen at the symmetrical center of the part.